all ravens are black?
The raven paradox, when a red apple confirms that all ravens are black. If every time I go to the beach without sunscreen I get a sunburn, it stands to reason that a subsequent visit under the same conditions will produce a similar result. In epistemology, or in philosophy of science, the principle of induction deals with the confirmation of a universal law through observation. Obviously, no number of observations can definitively confirm a universal law. However, if we consider the statement, "all ravens are black," it seems reasonable to believe that, in the absence of counterexamples, each new black raven makes us more confident of the rule. In the mid-20th century, Carl Gustav Hempel formulated an intriguing paradox. Observing a red apple would confirm that all ravens are black. This statement may seem absurd at first glance, but we will see that it is actually logically correct. We will also see that not all logically correct statements are useful in practice. Hempel's logic is impeccable, but that doesn't mean that our intuition is wrong. If all objects of type A are also of type B, the observation of an object of type A which is of type B is a confirmation. Similarly, an observation of an object of type A which is not type B, a refutation. Here, type A is being a raven, and type B is being black. The statement, "all ravens are black," is logically equivalent to "anything that is not black cannot be a raven," by contraposition. If this equivalence is not immediately apparent to you, don't worry. Our mind often struggles with complex negative statements. That said, the equivalence between the two statements is undeniable. The sighting of a black raven confirms the statement, and the sighting of a non-black entity that is not a raven confirms the second formulation. The principle of induction was therefore applied to the two equivalent versions of the statement. Do you see the paradox? Our intuition tells us that the observation of a black raven is relevant, while that of a red apple is absolutely not. When we take the point of view of Bayesian probabilities, we obtain a solution to the paradox and at the same time discover interesting and useful tools. The famous Bayes' theorem explains to us how to update the probabilities of future events in the face of the most recent observation. This is, in my opinion, the most important principle in probability theory. To clearly illustrate the problem, we will consider a simplified universe of 27 entities. In this universe, there are 4 ravens and 20 non-black entities, including a single white raven. The universe also contains 4 black entities that are not ravens. Here, the universal statement is false, in both forms, since there exists a white raven. In this context, the contraposition leads us to consider two situations qualitatively similar, but quantitatively very different. When exploring this universe, the probability of observing a white raven starts at 20% and increases rapidly for every raven observed. However, for non-black objects, the probability of observing a white raven starts at 5%. Even in this extremely simple universe, we notice a huge difference in utility between observing a raven and observing an object that is not black, like a red apple. It is important here to understand that in both cases, with enough observations, we will be confronted with the counterexample. Paradoxically, when it comes to refuting a universal statement, observing the white raven has exactly the same effect on both versions of the statement. In this universe, it is as false to say that all ravens are black as it is to say that all non-black objects are not ravens. The paradox must be considered in the real world. In this context, observing a red apple brings a negligible quantity of information due to the size of the sets involved. Fortunately, negligible does not mean zero. The principle of induction is safe. The scenario presented by Hempel is not without interest. It highlights the fact that certain observations are more relevant than others, a conclusion that should shock no one. This kind of exercise is very useful for understanding the concept of induction, but also for introducing Bayesian probabilities. Integrating new observations to update probabilities using the Bayesian approach is an essential method in a plethora of areas and in particular in data science. Finally, this example illustrates the danger of applying a theory in a regime where it loses its relevance. If a theory works at a specific regime, here with 27 entities, it may not be relevant if the number of entities is almost infinite. In fact, if we go to the limit of an infinitely large universe of objects, we find that the observation of a red apple might not confirm that all ravens are black. This simply means that our perception of the world is more compatible with an infinity of entities than with a finite number of them. Think about it.